There's something out there, beyond the last planet, beyond the frozen realm of Pluto, in a darkness so complete that sunlight arrives as little more than a distant star. For nearly a decade, astronomers have been hunting for it. A giant, a phantom, a world that shouldn't exist but refuses to stop leaving clues. They call it Planet 9. But in 2023, we found something else, something ancient, something that might prove Planet 9 was never there at all. Or that it's far stranger than we ever imagined. This is the story of Ammonite, and the mystery it refuses to solve. Let's rewind. The year is 2016. Caltech astronomers Konstantin Bedygin and Mike Brown publish a paper that sends shockwaves through the astronomical community. They've discovered something impossible to ignore. 6 distant objects, frozen worlds, tumbling through the outer darkness, and they're all moving wrong. Their orbits, they're aligned, tilted in the same direction, clustered like someone arranged them. And in the random chaos of space, that doesn't happen by accident. The odds? 1 in 14,000. Brown, who famously killed Pluto by discovering it wasn't alone, makes a bold claim. There's a 9th planet out there, something massive, something 5 to 10 times the mass of Earth, lurking in an orbit so distant it takes 10 to 20,000 years to complete a single lap around the sun. This wasn't fringe science. This was Princeton. This was Caltech. This was the kind of discovery that makes careers and rewrites textbooks. The hunt was on. Observatories around the world turned their eyes to the outer dark. The Subaru telescope in Hawaii, the Las Campanas Observatory in Chile. Even citizen scientists joined the search, combing through millions of images. Years passed. Nothing. But the aligned orbits remained. The evidence kept staring back at astronomers like a riddle written in gravity. Something was pulling on these distant objects, something unseen, something massive. The question was simple: what? Then, 2023, a team using the dark energy camera, an instrument designed to map the entire visible universe, spots something in their data. An anomaly. A wanderer. Object designation, 2023, KQ-14. But astronomers don't call it that for long. They give it a name that echoes through deep time: Ammonite. Named for the spiral-shelled fossils from the age of dinosaurs. Because like those ancient creatures, this object is a relic, a witness to the birth of our solar system. And it's moving in ways that don't make sense. Ammonite is what we call a trans-Neptunian object. It lives in the Kuiper Belt and beyond, that vast frozen graveyard where failed planets and primordial ice drift in eternal night. Its orbit is extreme, highly elliptical, taking it from the outer reaches of the known solar system to distances where the sun is just another point of light. But here's what makes Ammonite extraordinary. Its orbit is detached. Most objects in the outer solar system interact with Neptune. They get tugged, pulled, their paths shaped by the ice giant's gravity over millions of years. But Ammonite doesn't. Its closest approach to the sun keeps it far beyond Neptune's influence. It's gravitationally isolated, untouched, pristine. Which means something else put it there. Detached orbits are rare, precious, because they preserve information from the solar system's violent youth. A time when planets migrated, when orbits were chaos, when gravity was still sorting out who belonged where. Ammonite is a time capsule, and the message it carries is this: something massive sculpted its path billions of years ago. But what? Option 1, Planet 9. That hypothetical giant shepherding these objects into their strange orbits through its gravitational influence over deep time. Option 2, something else entirely, because here's the uncomfortable truth. We've been searching for Planet 9 for almost a decade, and we've found nothing. Not a glimmer, not a gravitational whisper, not a single pixel in any telescope image. So scientists have started asking a different question. What if there is no planet? Enter the alternative theories. 4.5 billion years ago, our solar system wasn't alone. It was born in a stellar nursery, a cluster of newborn stars packed close together. What if one of those stars passed near our outer solar system before drifting away forever? A close encounter like that would scatter objects, fling them into strange orbits, create the exact patterns we see today. No planet needed, just a cosmic hit and run that happened before Earth even existed. This one sounds like science fiction, but it's dead serious. What if Planet 9 isn't a planet at all, but a primordial black hole? A tiny one, maybe the size of a grapefruit, but with 5 times Earth's mass. These objects are hypothetical relics from the Big Bang itself. Too small to see. No light, no heat, just pure gravitational influence. It would explain why we can't find Planet 9. We've been looking for reflected sunlight, but black holes don't reflect anything. They're invisible. What if there's no single massive object at all? What if the strange orbits are caused by hundreds or thousands of smaller bodies, each one adding its own tiny gravitational pull? Like a school of fish, moving as one, these objects could create the illusion of something larger, a phantom made of dust and ice. And this is where Ammonite becomes crucial, because its orbit, its specific path through space, can help us test these theories. If Planet 9 exists, Ammonite's orbit should fit into the larger pattern. It should be another piece of the puzzle, confirming the gravitational fingerprints. If it doesn't fit, if Ammonite's orbit contradicts Planet 9's predicted influence, then we might be chasing a ghost that was never there. Here's why this matters beyond the mystery. The outer solar system is enormous, unfathomably vast. If you could drive a car at highway speed to the distance where Planet 9 might be hiding, the trip would take 60,000 years. And it's dark out there. Planet 9, if it exists, reflects so little sunlight that it's 1,000,000 times fainter than Pluto. Finding it isn't like looking for a needle in a haystack. It's like looking for a specific grain of sand on a beach that stretches across multiple continents at midnight. But we keep searching because the implications are staggering. If Planet 9 exists, it would be the only super-Earth in our solar system. Super-Earths are everywhere in the galaxy. They're the most common type of planet we've found around other stars. But we don't have one here. Finding Planet 9 would give us a laboratory, a world we could study up close instead of across light years. We could understand planetary formation in ways we never could before. And if Planet 9 doesn't exist, if these orbits are explained by stellar flybys or primordial black holes or collective gravity, that might be even more profound, because it would mean the solar system's history is stranger, more violent, more influenced by cosmic accidents than we ever imagined. Ammonite sits at the center of this question. A frozen witness, a cosmic fossil carrying secrets from an age before Earth had oceans, before life, before anything we recognize. Its orbit is a record written in gravity, and we're only just learning to read it. So is Planet 9 real? Right now, we don't know. The evidence is tantalizing but incomplete. The alternatives are plausible but unproven, and objects like Ammonite raise as many questions as they answer. What we do know is this: there's something about the outer solar system we don't understand. Some force, some history, some gravitational story that hasn't been fully told. Maybe there's a giant planet lurking in the dark, waiting to be found. Maybe there's a black hole the size of a fist, invisible and ancient. Or maybe the answer is something we haven't even thought of yet, but out there, beyond the light, Beyond the edge of everything we know, something left its mark, and we're going to find out what.